Okay, I got you. Is that what?
Yeah, I mean, it takes so long for the line feed to pop up.
Okay.
Right.
We have people yet?
Not quite yet. But it's just, it's not even less than 155 yet. It's under one.
Those clocks are just a little bit fast.
1 or 2 minutes fast. Take your time. Once people start coming in, I'll make the rest. Make it quick. No.
Anybody yet?
I don't think so. No, nobody's there yet. I provided the link, and I messaged them.
I met.
Okay, now I'm seeing.
There we go.
All right, come on now, guys. 7th period.
Vertical trip one more time.
I mean, according to my phone, it's 1:55 now, so we should have some.
Start hopping in.
Yep.
Yeah, that clock is a little bit slow.
Yeah, I mean, we only have 10 people in my room. So once you have 30 on this one, 20.
I think it's like 15.
Oh wow! So this is small.
This is a small one.
All right, let me do it. I'll do it.
All right.
I'm competitive and I want to improve on my time. All right, you got 1, 2.
Got it, 15.
You have about 7 now.
Okay.
Hey guys, happy 7th period. Today's Wednesday. Mr. Wynn's going to do the lecture, but I figured I'd just hop in here for those of you that are on. Hi, how are you? Make sure you have something to write with, something to write on, piece of paper, notebook, binder, using the notes feature on your computer so that you can kind of follow along with us as we talk a little bit about the metric system. So hang tight, we'll get started. I see a whole bunch of people that are starting to come on now, so hang tight and we'll get going. All right.
One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we got.
We're going to wait about 2 more minutes for people to populate, and then we'll go ahead and get started after 2 minutes.
So far. Yeah, let's do it.
Alrighty, welcome to 7th period, live lecture, second live lecture. We're very, very excited to make sure that we're able to present this material for you. So we're going to be talking about the metric system today. Now, some things to talk about with the metric system is it was developed by the French in the 1700s, and it was also based on the powers of 10. Now, the reason why that's important is because it makes it very, very easy to convert from one unit to the other. So just about every single country uses the metric system except the United States. It's especially used in science, and definitely by scientists. And in terms of the SI unit, you're going to hear this quite a bit from me, Mr. Ewald, Mr. Listerman, or Ms. Becker. We're going to be saying SI unit a lot, and what we're really saying is the System International, or just simply the metric system. So in terms of the metric system, there's some metric prefixes that you're definitely going to have to, that you're already familiar with. So in terms of the entire metric system, we have things like kilo, centi, milli, that are very common among our own vocabulary. So whenever we're talking about things like century, that's 100 years. We're talking about a cent, that is 1/100 when we're talking about dollars. And so there's a lot of things that we definitely are able to draw from common vocabulary that we get from these prefixes. Kilo is 1,000, centi is 1/100, and milli is 1/1,000. Now, what's really cool about the metric system is that, again, really easy to convert. 1 meter is equal to 100 centimeters. 1 meter is also equal to 1,000 millimeters. If we were to use the system that we have, if we're talking about length, how many feet are in a yard, how many yards are in a mile, how many miles are in a furlong, how many furlongs are in a league, all of a sudden it becomes really, really confusing. So we want to make sure that we have something that's very consistent, very, very easy to understand amongst a lot of people in the world. Now, don't get intimidated by this chart. This chart is a list of all the units that you may see throughout the year. So we have mega, kilo, hecto, deca. Then we have our base units, and we'll talk about what those base units are: deci, centi, milli, all the way down to a nano or even an angstrom. Okay, so in terms of the base units, so these right here, this is going to be our meter, our liter, and our gram. And what you're going to notice is that we have these numbers, again, are based off of powers of 10. So we have 1,000 all the way to 1, all the way to 1 to the negative 9th. So again, all of these are based off of a power of 10, so it makes it very easy to convert from one unit to the next. Now, the first tool that we use in biology is going to be a ruler in order to measure length. And so length is the distance between 2 points. The SI base unit is going to be the meter. And so we're going to use a ruler and meter stick in order to find the length of different objects. So, question number 1, what would be the appropriate unit of length for the following measurements? So if we have kilometer, we have meter, and we have our millimeter as our examples. What do you think the answer is for the thickness of your fingernail? What do you think it is for the distance between your house and HHS? And what do you think it is for the height of the roof of your house? So in this case, you're using these 3 measurements here. Why don't you go ahead and put that in chat. So let's say last names A through M. Okay, so last names A through M. Go ahead and tell us what you think the appropriate unit of length would be for those different scenarios.
All right, last name A through M. Go ahead and put those answers into the chat. All right, we got some answers coming in here. It looks like most people are saying A, the thickness of your fingernail, that's a millimeter. B, the distance between your house and HHS would be a kilometer. And C, the height of the roof of your house would be meter. Right? So it looks like most people are in agreement that it should go millimeter, kilometer, and then finally meter. Wonderful, wonderful, wonderful job, guys.
All right, good job, guys. So it definitely looks like we understand what the appropriate unit of length is. And whenever we're doing these problems, you want to make sure that you do put the units down. Okay, so we talk about naked units in biology. We don't want any naked units down. So in terms of kilometer, if you're using the kilometer, make sure to put down the fact that it is a kilometer. Otherwise, you're being inappropriate. Okay, so we're going to do a live demonstration with length. And so we're going to measure 2 items. We're going to measure an iPhone and the diameter of the tape using a ruler, making sure that we're able to read what's going on with the ruler.
All right, so I'm going to turn you guys around so that Mr. Wen can do our live demonstration of measuring the length of an iPhone.
Okay, so the first thing you're going to notice are these large numbers. And these large numbers indicate centimeters. Okay, so we want to make sure that we keep note of the centimeters as well as those small tick marks.
The small tick marks are going to be your millimeters. And so try to get as best as you can to the closest value that you can. Let's go with M through Z. So individuals whose last name is M through Z, let's go ahead and see if we can get that answer. Okay, so M through Z.
Don't push send on the iPhone.
So M through Z, what would be your estimate for the length of this iPhone using this ruler? We want to give our measurement in centimeters, and just like Mr. Wen said before, make sure that you put the units on there. Okay, what do you think the length of the iPhone is in centimeters? I'll give you just a couple more seconds of this view, and then I'm going to step away. Length of the iPhone in centimeters. All right. All right. So we are already starting to get some answers coming in here. Thank you to those of you last names N through Z. So we have 15 centimeters. We have 15.5 centimeters. We have 15 centimeters. We have 15 centimeters. We have 15.5 centimeters. Okay, so far that's what we have there. I would imagine that there will be some more coming in.
Okay, so good job on those answers, guys. The actual answer for that iPhone is about 15.5. So it's really hard to see with that clear case. So if you have close to 15.5, 15.6, 15.4, something along those lines, good job, guys. Okay, all right, we're going to do the diameter of the tape. Okay, so the diameter of the tape. So try your best guess at the diameter of the tape. Okay, so whoever's birthday is January through June. So if your birthday falls on January through June, let's hear those answers.
So again, we know that the images on the camera are not perfect, but what do you think that would be if you were trying to estimate the length of, or the diameter of the tape using that ruler in centimeters? All right. All right, so we're getting some answers in here. Thank you for that. We have 11 centimeters, 11.25 centimeters, 11.5, 11.3 centimeters, 11 centimeters, 11.25 centimeters.
Alrighty, guys, so if you have around 11.3, good job. That's what I think is the measurement of the diameter of the tape. Okay, so we're going to talk about precision and we're going to talk about accuracy. Now, precision is the exactness of a measurement. So it's how often you can hit a certain number or a certain point. So we saw a lot of precision in our answers, so good job on that. Accuracy is how close the measurement is to the correct value.
So we want to make sure that we do hit this correct value, but we want to make sure that the majority of people are able to do that. So I'm going to explain that through an example using Highlands High School. So Highlands is in Fort Thomas. That's accurate, but it's not very exact. Okay? If you were to ask somebody to go to Highlands High School, they've never been to Fort Thomas before, they'd be driving all over the place. So you want to make sure that you're a little bit more exact. Highlands is at 15 North Fort Thomas Avenue. If you told them that, then they would not be in front of Highlands High School. They'd be somewhere completely different. Okay? So that's precise, but it's not very accurate. Highlands is at 2400 Memorial Parkway, Fort Thomas, Kentucky. That is not only precise, it's also accurate as well. We want both in science. Okay? So really, really important to make sure that we're able to do both those things. The next characteristic that we're going to talk about is mass. So mass is the amount of matter that an object has. And so if we're looking at two different objects, we have a golf ball and we have a ping pong ball. We know that they're different masses, but they're relatively the same size. The reason why the golf ball weighs more is because it's made up of different things, and those things are heavier. So in this case, we want to make sure that we're able to calculate that mass with not only precision but also accuracy as well. So the SI base unit for mass is a gram. So to get an idea of what a gram is, a paperclip is about 1 gram. And the mass of an object will not change unless you add or subtract from it. So in other words, unless we break it, we cut it, we do something to that particular object, its mass will not change. So how do we measure mass? We use a triple beam balance in order to measure the mass. And we'll talk about how to use a triple beam balance here in just a second. But first, what I would like you to do is to make sure we understand what the appropriate unit of mass is going to be. So we have the kilogram, the gram, and the milligram. So what I would like you to do, if your birthday is from June to December, tell me what the appropriate unit of length is for the amount of vitamin A in an energy bar, the mass of a bowling ball, and the mass of a mouse. Okay, so again, if your last name is June through December, go ahead and put those answers in.
All right, throw those answers into the chat. What would be the most appropriate unit of mass for A, amount of vitamin A in an energy bar, B, the mass of a bowling ball, and C, the mass of a mouse? Kilogram, gram, and milligram. June to December birthdays.
So remember that we are on question 3, so hopefully you are adding this to your piece of paper, and because that is what you're going to be turning in at the end of this live lecture.
All right. They're starting to come in. We're getting those June to December birthdays. We have A, milligram, amount of vitamin A in an energy bar. We have B, kilogram, for the mass of a bowling ball. And C, we have a gram for the mass of a mouse. Everybody seems to be in agreement with those. Milligram, kilogram, and gram. Wonderful. Wonderful.
Alrighty, guys, good job on that. Again, we're just making sure that we understand the appropriate unit of measure. And again, remember, whenever we're doing these problems, you want to make sure that if you're talking about a kilogram, that you're using your units. All right, so calculate the mass of each triple beam balance below. So I want to talk a little bit about the setup of this triple beam balance. So this first bar here at the very back is your tens place. The bar in the middle is your hundreds place, and then this first bar is your ones place. So that whenever you look at all 3 of these numbers together, it'll give you the mass of that object. So that if we're looking at this particular mass of this reading for the triple beam balance, we know that this is going to be 30. We don't have to worry about the hundreds place. So it's going to be 37.3. Okay, it'd be 37.3. So we want to make sure that we understand how to calculate that particular mass. So we're going to do a live demonstration. Okay, so we're going to show you guys the first one for the mass of the following items. So we're going to have the iPhone, and we're going to mask that iPhone. We're going to show you first, and then we're going to have you guys read off the number for the masking tape.
All right. So we have our triple beam balance right here. Mr. Wen's going to show you all about this bad boy. All right.
Alrighty, guys. So the first thing, I already noticed a problem. We want to make sure that we zero this, okay? So all the numbers over to the left, so it's 0, okay? And we want to make sure that we have this particular line centered or level with that 0. So that's pretty close. All right, now, we're going to use an iPhone. All right, so there's our iPhone there, and I'm going to get started, okay? I'm just going to, let's do it that way.
Whoa.
What's wrong? What did I do wrong?
Well, if we just move them all willy-nilly like that, we're going to have no idea what the mass is. So there has to be a better way.
Oh, okay, well, let's start over again. So we're going to zero it out again. Okay, and I'm going to do this a little bit better. I'm going to start with the hundreds first.
I like that.
Okay, so we're going to go with the hundreds, and we're going to wait until it goes down. Okay, it's starting to go down there. Oh, it's definitely down at the 300. So I'm going to move it back to the 200. Okay, so we notice that it's up. Okay, so it's up, so we know that we need to move to the next unit, which is going to be the tens. We're going to move that. Okay, so we've got to move back, and that stays up. Okay, and so we're going to go with our last one, our ones. All right, Mr. Ewald, can you do me a favor and read off that mass?
You got it. So if we look at the hundreds first, we have 200. If we look at the tens, we have 10. So we're at 210. And then the next thing we're going to do is come down to the ones here. That is at it's between 3.3 and 3.4. So we would be good with either 213.3 or 213.4 would be a good measurement estimate for the mass of that iPhone.
Awesome. Awesome. Good job. All right, so let's do the masking tape next. Okay, so that masking tape, again, we want to make sure to zero this out. Move everything over to the left. We're going to start with the hundreds, drops, so we got to move it back, and then we're going to move this until it goes down. Okay, it went down for the 100, so we're going to move back to the 90. Okay, and then we're going to use this. Alrighty, your turn, guys. So let us know what you think that mass is. If you were born on a day that ends in Y, I want you to give us the answer. Okay, so you were born on a day that ends in Y. I want you to give us the answer.
What is your estimate for the mass of the masking tape based on this triple beam balance? What do we think? we got some answers coming in hot and heavy here. We have 95.5. Oh, 95.5. We want to make sure that we have those units on there. We have 95.5 grams, 95.6 grams, 95.5 grams. So it looks like we are right around that 95.5 grams or 95.6 grams.
Alrighty, good job, guys. That is absolutely 100% right. 95.5 or 95.6. It hovers around that number.
Alrighty, the last physical characteristic we're going to talk about is volume. So volume is the amount of space an object takes up. So if you have a regular shaped object like a box, then you can find the volume very, very easily using the length and width times the height. Okay? In biology, we typically don't have just boxes. We have all these different irregular shapes. So it's going to be important to make sure that you apply the correct equation to calculate the volume. Okay? A lot of times as well, you can also use water displacement in order to find the volume. So we want to make sure that we definitely are able to calculate what that volume is going to be. In this case, the unit would be cubic centimeters, so centimeters cubed, because if we were to measure that as a centimeter, this is a centimeter, and this is a centimeter, and this one as a centimeter, then you would be able to calculate what that particular volume is going to be. Okay, so the base unit for volume is going to be the liter. So we use a graduated cylinder in order to measure the volume. And Mr. Ewald, why do they call it a graduated cylinder?
Ooh, I would say because it's been educated, Mr. Wayne.
Okay, absolutely 100%. I'm sure it's been educated because it graduated. Okay, but it also has to do with the lines on the side of the glass as well. That's a good dad joke, by the way. Okay, so in terms of the graduated cylinder, whenever you have a volume that is inside that graduated cylinder, what you're going to get is you're going to get this nice little bend due to adhesive forces of that liquid that sticks to the side of the tube. So that curving is called a meniscus. And so what we want to do in order to make sure to read a graduated cylinder correctly, we're looking at the very bottom of that meniscus. Okay? So very, very bottom of that meniscus. So that if we have this graduated cylinder, it's filled to this line here, which may be hard for you guys to read at home, but this is a close-up view, and what we see, if we're using the meniscus, is that that's going to be at 43 milliliters. And generally, a graduated cylinder is measured in milliliters. So we're going to do another live demonstration with the volumes, and we're going to look at 3 different graduated cylinders.
Now, I apologize ahead of time. It's really hard to focus on the volume. So we're going to have just Mr. Ewald's class. So if you are in Mr. Ewald's class, why don't you go ahead and tell me what the volume is for this graduated cylinder here, number 1. This graduated cylinder here, number 2. Okay? So what is the volume of these 2 graduated cylinders?
So Mr. Ewald's class, let's get those answers coming in. What would be your estimate for the volume of liquid in graduated cylinder 1 on the left and graduated cylinder number 2 on the right? What do we think? Pay attention to that meniscus, do the best you can. to get an estimate for the volume.
Alrighty, as those answers are rolling in, we're going to do our third graduated cylinder. So still Mr. Ewald's class. Okay, what would be the volume of the third graduated cylinder?
All right, so we have some answers coming in for graduated cylinder number 1 and graduated cylinder number 2. Looks like we have 6.6 milliliters for graduated cylinder 1, 6.7 milliliters for graduated cylinder 1, 6.5 milliliters. Graduated cylinder number 2, we have 17 milliliters, 17.5 milliliters.
Okay, now, one of the things is if you were in person, this would be so much easier to do. So it's really, really difficult to be able to see it through this webcam. So if you have, for number 1, 6.5 to 6.7, you're absolutely 100% right. Okay, so good job on that. I know, again, it's very, very difficult to see, so we apologize for that. For graduated cylinder number 2, we're looking at 17 milliliters. Okay, so we're looking at 17 milliliters.
And then we had some answers for graduated cylinder number 3. We had 47 milliliters, 46 milliliters, 46 milliliters. So we're looking at 47 or 46 milliliters being our answer for graduated cylinder number 3.
Okay, good job, guys. So that answer is going to be right in between. So it's going to be 46.5 milliliters. So if you wrote down 46 or 47, I would also count you right as well.
Nice work, guys.
Now, we said that the metric system was very, very easy to convert. Okay, in terms of conversions for mass to volume, that's also something that we can do as well, which again makes this so useful in science and also in talking about those results. So 1 cubic centimeter of water is equal to 1 ml of water is equal to 1 gram of water. So it makes it very, very easy, especially in chemistry, to be able to convert from volume to gram in order to figure out how much of a liquid you need. Now, so the basic metric units, we've talked about meter, and we talked about length, we talked about gram and mass, we talked about liter and volume, and now we have a couple of other basic metric units that you'll have to kind of just familiarize yourself with. So in this case, with the temperature, we have Celsius and Kelvin, and then for time, we also have seconds as well. So for Celsius, we have these numbers. 30 is hot, 20 is nice, 10 is chilly, and 0 is ice. That is not what we follow. Okay? So in terms of our everyday life, we're looking at Fahrenheit. So it's very, very uncommon for us to use Celsius in order to refer to the weather. So we have 32 degrees Fahrenheit, which is ice, okay, water freezes, and we have 212 Fahrenheit where water boils. So it's a very different system, and it's a lot more complicated than what we have for the Celsius, which is really just a scale of 0 to 100. Now with the Kelvin scale is used for those scientific calculations in math and also in physics, and also in chemistry as well. So no negative numbers, and at the very, very low point of the Kelvin scale is absolute 0. The last thing we're going to talk about today are conversions. So, in terms of conversions, if we can go from one unit to the next, we can very easily just move the decimal point in order to make sure that we're able to convert from one unit to the next. So, either we're going to move left or right, and what you're going to notice is that if you have a smaller unit and you're moving to a bigger unit, your number is going to get smaller. Okay? And vice versa is also true as well. If you have a bigger unit and you're moving to a smaller unit, that number is going to get bigger. So what I want you to do is I want you to convert 422 centimeters into what you think how many meters that is. Okay? So let's say if your last name is A through M, okay, A through M, 422 centimeters equals how many meters? Go ahead and put that in chat.
All right, we got them coming in now. 422 centimeters is equal to 4.22 meters, 4.22 meters, 4.22 meters, and so on. Everybody is 100% correct.
All right, good job, guys, in terms of those conversions. Okay, so do me a favor, go ahead and start working on the other conversions. We're going to give you about 2 minutes in order to do that. So 69.63, 9.23, all those different ones. And as you're doing it, I'm going to go ahead and work them out so that you guys can see what I'm doing in terms of moving that decimal point.
Milliliters.
Alrighty, guys, so it is just about moving it either to the left or right, depending on whether or not you are converting it to a bigger unit or to a smaller unit. So moving 3 to the right for the liters to the milliliters. So we're going from a large unit to a smaller unit. So you can see that the number is getting bigger. Okay? Moving from a smaller unit to a larger unit, you can see that that number gets smaller. So that's what I wanted to show you in terms of using that scale. So again, we will always give you the conversion chart. You don't have to worry about memorizing that conversion chart, but we wanted to make sure you knew how to work out the problems. Now, what if the system that you're trying to convert isn't off of a base 10, if it's not a factor of 10? So let's use money, because everyone is very familiar with money. So 22 quarters, 7 dimes, 9 nickels, and 75 pennies. How much money would Vinny have if he were to add all this up into dollars? Okay, so the first thing that we have to consider is how many quarters are in a dollar? How many dimes are in a dollar? How many nickels are in a dollar, and how many pennies are in a dollar? So we're going to use a conversion factor in order to figure out what that answer is going to be. So whenever we are converting, what we want to do is we want to figure out, okay, there are 4 quarters in $1, and what you're trying to get rid of, the unit that you don't want, goes at the very bottom, goes to the denominator. So once you do that, you can cancel them out. Then you're just going to multiply across 22 times 1, 4 times nothing else, and you're going to get 22 over 4, which is $5.50. Okay? So you're going to do the same thing for all the other ones, for dimes, nickels, and pennies, in order to figure out how much money Vinny has. So if you can figure out how much money Vinny has, why don't you go ahead and put that down in the chat. Okay? So let's do everybody. So everybody, if you know what that money is for Vinny and how rich he is, make sure to put that in chat.
What do you think? How much money does my boy Vinny have? He's got 22 quarters, 7 dimes, 9 nickels, and 75 pennies. How much money does he have? I don't know. I guess he has no money. No answer, so Vinny, no money. Oh, here we go. Just took us a minute to do a little bit of the math.
Okay, that is the conversion chart there. And Mr. Ewald, what's the amount?
$7.40.
$7.40. Oh my goodness, that's a lot of money. Okay,
Rich.
I'll buy you a lot of candy bars.
Amen.
All right, so any other questions that you guys have? So we want to make sure that we answer all your questions. I know that for the metric system and the conversions, there may be issues with that, but you want to make sure that you email us, Mr. Ewald or I, about those questions. Make sure to turn in your questions by the end of your class period. So all the things that you wrote down for this live lecture, check Schoology to see whether or not your teacher has assigned any more work. There is independent work for me. There is independent work for Mr. Ewald. Mine is due on Friday, so is his. So you want to make sure to turn that in. And then our next time-bound event will be either small groups or individually. So again, get with your teachers about what that's going to look like. Thank you guys so much.